Hello from Mindpads. TOK Essay, November 2017. Topic number 2. Every theory destabilizes as much as it solidifies our view of the world. Nathan Jorgensen. Discuss. Knowledge question 4. Does new knowledge produce new forms of non-knowledge in natural sciences and mathematics? In physics, Newtonian models were crude approximations of the truth, and similarly in biology, the Mendelian processes have turned out to be an even greater simplification of reality than Newton's laws. The discovery of gene-protein interactions and other aspects of epigenetics has challenged the view of DNA as destiny and even introduced evidence that environment can influence inheritable traits, something once considered a genetic impossibility. The more we learn in any area of knowing, in evolutionary biology for example, the further we find ourselves from a model that can explain it. The physicists have long encountered ignorance about disorder in the atmosphere, in the turbulent sea, in the fluctuations of wildlife populations, in the oscillations of the heart and the brain, the irregular, non-linear, erratic and discontinuous side. And where classical science stops, chaos begins. Relativity eliminated the Newtonian illusion of absolute space and time. Quantum theory eliminated the Newtonian dream of controllable measurement process. Chaos eliminated the Laplacian fantasy of deterministic predictability. For additional content, read more at Mindpads.org. Knowledge question 5. In a multi-dimensional, complex, dynamic world, with big data and multiple correlations, to what extent is it possible to theorize all the generated data? In our multidimensional, complex, and dynamic world, where facts, data, information, and observations are minted out uncountably, where knowledge is increasingly outpacing even the requirement of understanding, where we do not wait for understanding to catch up with knowing, where events are increasingly the products of chaotic combinations, and there is no room for explanation except for detailed description, are there, or can there be theories for everything? And if it makes it easier to accept, there need not always exist human comprehensible theories behind correlations of big data. We should get used to the idea that we're going to know some things without understanding them. We will be able to reliably predict outcomes, but not understand exactly what drove those outcomes, through building elegant and intelligent computer models using trillions of bytes of data. We can predict because we can build intricate computer models using metric tons of data without having a theory. Knowledge question 6. Are we moving towards end of theory with the flood of facts and the deluge of data? Unlike in the past, when systematic data was scarce, big data is getting bigger and computing power is getting cheaper by the minute. In our present world, massive amounts of data are applied mathematics are replacing every other tool and every other theory of human behavior, from linguistics to sociology. The hypothesized model test approach to science is becoming obsolete and is influencing the research practices of corporations, states, journalists, and academics. The idea being that data shadows and information trails of people, machines, commodities, and even nature can reveal secrets to us that we now have the power and prowess to uncover. In other words, we no longer need to speculate and hypothesize. We simply need to let machines lead us to the patterns, trends, and relationships in social, economic, political, and environmental relationships. Knowledge question 7. In what ways are facts or data perfect partners with theories? Francis Bacon believed in facts, data, and observations, and he also believed that theories should seek the physical causes underlying observations so as to predict the results of observations not included in the data that generated the theory, and that theory and experiment were partners in the quest to generate sound science for the benefit of society. And yes, with only grainy and fuzzy data, you cannot have a good theory. Galileo could not see the Saturn rings, and he came up with a probable model of Saturn rings with very different and incorrect diagrams that Christian Huygens catalogued, before he came up with a better theory for Saturn rings equipped with a better telescope getting rid of all that grainy data. Being a renowned theorist, Richard Feynman paid a sparkling tribute to the supremacy of experiment when he said, "In general, we look for a new law by the following process. First, we guess it. Then we compute the consequences of the guess to see what would be implied if this law that we guessed is right. Then we compare the result of the computation to nature, with experiment or experience, compare it directly with observation to see if it works. If it disagrees with the experiment, it is wrong. In that simple statement is the key to science. It does not make any difference how beautiful your guess is. It does not make any difference how smart you are, who made the guess, or what his name is. If it disagrees with the experiment, it is wrong." That's all for today. Thank you for watching. For additional content, visit us at mindpads.org, and for any queries, write to us at mindpads.org@gmail.com.